Today we're going to look at multiplying fractions and in particular how we can cross-reduce before we actually go and multiply our fractions together. So remember when we talk about multiplying fractions, we were talking about going straight across the numerator and straight across the denominator. Before we do that though, one really good strategy, and we've talked about this before, and today I'm going to show you how I think about this. Anytime we multiply fractions, the first thing I'm looking at is, can I cross-reduce? And the reason we want to cross-reduce is because we want to have simple numbers, meaning smaller numbers which make our multiplication and calculations easier. The other reason is it ends up making the multiplying fractions quicker. We can avoid large numbers when we multiply, and it helps simplifying our answers to a point where we don't have to do anything most times when we finish. So when we cross-reduce, we want to look at our diagonals, so the numbers that are across from one another. So in this case, we're looking at 2 and 10 and 3 and 9. So when we look at 2 and 10, we think about the numbers that they share in common. And if we write them out, so the factors of 2 are 1 and 2, and the factors of 10 are 1 times 10 and 2 times 5. Now once you get good at this, you don't necessarily have to write these all out. You probably recognize, some of you may have recognized right away that the largest number that these two share is 2. So now we're going to go back and we're going to divide both of these numbers by 2 to kind of simplify this before we even multiply across. So 2 divided by 2 is going to give us 1. 10 divided by 2 is going to give us 5. We're going to do the same thing with the other diagonal. So 3 and 9. So the factors of 3 are 1 times 3, and the factors of 9 are 1 times 9 and 3 times 3. So the largest one that these two share is going to be 3. So we go back up top and say, all right, well, I can divide each of these by 3. So 3 divided by 3 is going to give me 1. 9 divided by 3 is going to give me 3. Now I've got smaller numbers. I don't have to reduce once I get my answer. My answer will be final. So when I think about when I multiply now straight across, I've got a positive fraction times a negative fraction, which means our answer is going to be negative. So I'm going to do that right now. I'm going to go write the negative sign so I know. In my numerator, I've got 1 times 3. So that's 3. Denominator, I got 1 times 5, and that's 5. And this last step is done now because we already did our reducing before. So our final answer of 2/3 times negative 9/10 in lowest terms is going to be negative 3/5. All right, now let's take a look at another example using the same thinking. So again, if we focus on our diagonals here and here, and 3 and 9, are there numbers that these share? Sometimes it may not happen. Sometimes you may not be able to cross-reduce. In our case, if we look here and we think about numbers that 4 and 8 share. So 4, we got 1 times 4, and 2 times 2. And 8, we got 1 times 8, and 2 times 4. So the largest one that these two share, we can see is 4. So again, if I go back up top and I look and say, okay, I'm going to divide each of these by 4. Well, 4 divided by 4 is 1. I'm going to do the same thing over here. 8 divided by 4 is 2. And now looking at our other diagonal, we've got 3 and 9. Well, 3, we just have 1 times 3. 9, we got 1 times 9, and 3 times 3. And so we can see right away that 3 is going to be the largest. And again, once you become comfortable with thinking about factors and the greatest one that they share, you don't have to write these out. I'm writing these out so that you guys can all see this and see my thought process as I go through. So if I go back up top, I use 3 divided by 3. Again, I get 1. 9 divided by 3, I get 3. Now that I've cross-reduced, I've simplified it for myself, now I know when I multiply across, I'm good. My answer is final. I think about, again, I have a negative here times a positive. So again, our answer is going to be a negative. I'm going to write that right now so I don't forget. And now I've got small numbers to multiply. 2 times 1, I got 2. 3 times 1, I got 3. So my final answer, in lowest terms, of negative 8/9 times 3/4 is negative 2/3. Let's go back up to the top one and take a look at what it would look like if we didn't cross-reduce and what we would have to do. So we've got 2/3 times negative 9/10. So we'll grab a different color. 2/3 times negative 9/10. So if we followed our just rules of straight multiplication, which we certainly can do, we know there's a chance we may have to reduce at the end. But if we just do this to see, so 2 times 9, and I know that a positive times a negative, again, is going to be negative. So I'm going to go over here and write that. 2 times 9 is going to give me 18, and 3 times 10 is going to give me 30. So if we look already, if I scroll back up, we had this as our final answer up here. So this doesn't match this right now, meaning this needs to be reduced. So if we go back here and we think about now, all right, I've got this step. I know I need to know my factors of 18 and my factors of 30. Well, if you think above, we use much smaller numbers when we had to list our factors. So these ones are a little bit bigger, and it may require a little more thinking. So factors of 18, I've got 1 times 18. I've got 2 times 9. I've got 3 times 6. And if I think about 4 and 5 are not factors of 18, so those are it for 18. But I need to do the same for 30. So 1 times 30, 2 times 15, 3 times 10, 4 will not, but 5 will, and that multiplied with 6 will give us 30. So if we look now, we need to find the largest common factor these two share, and if we look, it's right here, and it's going to be 6. Meaning we need to go back up to our answer here and divide each of these by 6 to put it in lowest terms. And when we do this, we should get the same answer as we did above, but doing more work. So I know it's still going to be negative. 18 divided by 6 is going to be 3. 30 divided by 6 is going to be 5. So I get negative 3/5. Now let's go check. Negative 3/5 and negative 3/5. So there's nothing wrong with doing straight multiplication across your numerator and your denominator. You do have to understand that you run the risk of getting to a point here where it's not fully reduced. When you look to cross-reduce first, you have a better chance of getting a fraction that is already in lowest terms. Okay, so again, really the key points of why we want to cross-reduce is we want to deal with simple numbers. We want the small numbers, which make our calculations easier. We also want quicker results. Like if we think about the process here and the second one at the bottom, you probably would agree that I was able to go through both of those much quicker than I was if I didn't cross-reduce first. I also avoid, having to multiply large numbers and then simplifying at the end. If we can simplify before, which we are when we cross-reduce, it kind of helps save us some time. I hope this helps, and hope it also explains cross-reducing a little bit better, and that maybe we're more open to trying this in the future.